We're looking at the number of Medicare enrollees as a function of years since 1980. We have a quadratic model, and we want to interpret some of the parameters here. So first thing I suggest doing is, as you're getting good at these things, working to get better, is to draw a little table. Let the table help you out just a little bit. So we know that C is the initial value. Well, when we put in 0 for time, representing the year 1980, the output is 28.4. So C is equal to 28.4. What does it mean? Well, it means that in 1980, because this is really the ordered pair 0, 28.4 that we would get, number of Medicare enrollees is 28.4 million. Okay, so there's our starting value. So we have our starting value here, and I'll just work to kind of sketch it just to get an image. And now I know that initially the rate of change is 0.663. Well, 0.663 what? So if I look at this, well, the output, since this is initial rate of change, is measuring million enrollees, and T is measuring years. So B, being 0.663, must be in Medicare enrollees, or sorry, million enrollees per year. In other words, initially we have an increase in the Medicare enrollees, and that's the rate of change. Now, it's not always the rate of change, because we have this guy who's contributing negatively to the linear components here, the 0.663t plus 28.4. That's a linear function, but we have this guy here. So we start to build out our change table, and we notice, hey, look at the changes. The rate of change is actually getting smaller. The Medicare enrollees are increasing, but at a slower and slower rate. At what rate is it decreasing? Well, remember, twice A, 2 times A, is equal to this delta, 0.00, sorry, just 2 zeros, 944. So that's twice the value of A. Well, that tells us that each year, the growth in enrollees decreases by 0.00944 million enrollees per year. So every year it drops by that, the increase drops by that much. The Medicare enrollees are still increasing, but at a slower and slower and slower rate. Now, if we continued to subtract from the rate of change, we would eventually, ideally, see that this is going downwards. But we don't know what's going to happen after that. We're only looking at the first 9 years. But it looks like it's slowing down, and if the rate of change continues to slow down, eventually it will reach 0, and it will keep subtracting from that. The slope will start to become negative over time. Now, will that really happen? Hard to say.